zero to hero, basically a cloud engineer, like cloud engineer zero to hero, mainly focusing on Azure. Throughout the last 8 weeks of last year, I think we stopped on the 15th December. What we are doing, we started with AZ900. So we started with AZ900 to look at, okay, what is Azure? We looked at what these different services in Azure. We looked at looked at load balancing, looked at networking. We did practicals, right? This year we are going to go a bit more, right? So this year we want to start with something. We want to start with Kubernetes. So you guys are aware, everybody's singing AI, AI, AI. AI is basically what is changing everything now. What AI is basically controlling everything. Everything if you're in IT now and somehow you've not heard the word AI, huh, okay. So the truth is that the AIs, all these are being hosted on somewhere, right? They're being hosted on somewhere, and if you're an AI engineer, somehow, somewhere, you're going to run into things like Docker. You're going to run into things like Kubernetes because your machine learning models, you have to train them somewhere on an infrastructure. So if you're training them on infrastructure, for example, like a Kubernetes, you need to understand the basics of Kubernetes. So throughout this class, yeah, it's a lab session. But more importantly, what I would like you to understand is understand the basics. It's really important. So, for example, now I was going through a boot camp recently, and they were talking about Docker, they were talking about Dockerfile. But because I understood those, because I understand that, you can vibe code, right? You can all use ChatGPT, give ChatGPT, or give Gemini, or whatever tool you want to use. But if you people that actually make use of this understand very well, people understanding the underlying infrastructure, what's the difference between a Docker within a container and a virtual machine? Where should I go for one, right? What microservices. So today we're going to introduce all that. Hopefully get to Docker. I'll hand over the lab. The lab is actually in a GitHub link, so you can go to GitHub link. You can do it locally on your system, or you can do it through a browser. That's the idea. But the idea is that at the end of this series, right, we want you to be able to understand the language of the internet, which is basically called Kubernetes these days, right? What is Kubernetes about? We're going to zero in on AKS, but we're not going to run it through our training running on AKS. AKS is going to be the last part because if you understand Docker and Kubernetes, whether it's running on AKS or you're running on EKS, which is Amazon known, or you're running on GKS, which is Google known, or Linode known, is basically the same, or you're running locally on your laptop, is basically the same. So we're going to start with today. So today I'm going to say Azure Kubernetes training. For people that just joining, my name is Nonso. I'm currently based in Netherlands. I'm a Nigerian currently based in Netherlands. My colleague here is Dominic. He's still he's currently based in Nigeria. He works remotely with a Canadian company. And we have our MVP board. I think he's in transit now. He's transiting to Netherlands, but he's not available right now, so it's too good. So hopefully by next week you'll be able to join us in this training. So, but if you have any questions, you can just drop it in the chat at any time. Sometimes I can stop to answer the questions. Sometimes Dominic can pick up the questions. That's how we flow. It's basically like it's basically free. Like I say, the class is free, so there's no hierarchy here. If you have any questions, just drop it at any time. If there's something you're bothering, maybe it's not even related to AKS, we are here to help, right? Thank you. Okay, so we're starting. Module one is basically the basics. We're going to introduce Docker and Kubernetes, right? We're going to do microservices, DevOps, Docker, Kubernetes, right? We're going to introduce all that. Started. So the learning objectives in this one say, what of software evolution, right? How do we get to this place we are right now? Right? I know we are all singing AI anthem, but even AI is really written on what Fast API, React for the front end, Fast API for the back end. To call the models, call the AI models. All these are you still need to know the basics. So how do we even get to there, right? Overview of monolith. What is monolith? What is microservices? What is DevOps? Right? We're going to do introduction to Docker containers. Right? I'm going to look at, okay, hey, what are Docker containers? What are the Docker container basic commands, right? Then we're going to look at Kubernetes fundamentals. What is the whole Kubernetes architecture? Then we're going to look at the YAML basic, because YAML basically stands for yet another markup language. YAML stands for yet another markup language. What is it all about? Okay, hey, what was it even used for, right? It's basically used the configuration. And most things you are deploying on DevOps these days is indoor configured with YAML, right? Whether you are doing Ansible, or you are doing Kubernetes, you are doing, most of them are being written on YAML, right? Then the next thing, we're looking more into Kubernetes concepts. We're looking at some of the concepts of Kubernetes, right? We're going to look at the basic ones. We're going to look at pods. What are pods? We're going to look at replica sets. We're going to look at deployments. We're going to look at namespaces. We're going to look at services. We're going to look at config maps. We're going to look at secrets. We're going to look at volumes in Kubernetes. So just to put it, this class is just for an hour and 30 minutes, because we don't want to overwhelm people's weekend. So we might not be able to finish all of this today. So, but this is a continuous series. So next week, anyway, we stop this week. We're going to continue again next week. Solomon, do you have a question, or you're just doing a thumbs up? Thumbs up. Okay. All right. Thank you. All right. Okay. So software evolution. How do we get to this place? Monolithic applications. What are monolithic applications, right? I'm going to tell you, in the world, all the world where they go, the time I knew John, right? When we worked together far back in UBA, what monolithic applications? I once worked with a team called data center. How do we work, right? Hey, Helen, nice to see you again this year. Helen will come. Helen is a developer. Helen writes application. Helen is very, very good Java developer, right? Java developers, they made a lot of money of .NET developers. He is a very good Java developer. He will write this application, both the back end, the front end, the JRE. She will write everything. Helen is the one that owns the application. Helen, nobody tests the application. Only Helen tests it in the laptop, concludes as a monolith. The end. So all business. So if it's application, let me see, for example, let me use banking, for example. Since all through my life, I think I've only 2 of my jobs are not in bank, right? All of my jobs are mostly being in bank. So let's say the application is a key. Let's say this application is into customer service, right? The application is a customer service application. So if you have a front end whereby users will come, hey, I want to take, let me say it's a checking application, people will pay in check, right? So Helen is writing this application. Now Helen will use Java to write the front end. Front end will be, hey, people come and deposit their check. The teller picks the check, you put it in a browser, in a table, some kind of form that Helen built, right? This compiles and stored in the backend database. Helen will write this with Java end to end, right? Helen, there is no front end about it. Helen will write everything end to end. Helen will start this application with his laptop, conclude with his laptop. UAT, user accepted testing, will be done in Helen's laptop. Helen will now come and meet so the data center team and say, hey, I need the server that will host this, right? That's what Helen will do. That's monolith. The end-to-end of application, everything about the application is done by probably 1 or 2 or 3 more persons or 4 persons, but it's already done in one language. Another thing to note with monolith is basically monolith always makes use of what we call the waterfall method. What is waterfall method? Waterfall is like, hey, I come and meet Vincent. Vincent, good evening. Vincent, how are you? Vincent, I want you to build me an application that does this. I want to build an application that, let me say, application that checks when a barber is available, so I can go and cut my hair. Let me use that for example. Vincent now said, hey, okay, I'm going to give me all the things you need. You say, okay, hey, this application is just something very simple. It checks all the barber available, asks me whether the barber, brings the barber to know where the barber is available, and emails me and tell, hey, this barber is available, go and cut your hair. Okay, so this is a written custom application for me now and giving it to me. The whole waterfall method is that I cannot come tomorrow once the agreements I've given Vincent what I want from this application, what I want the application to do. I cannot come back tomorrow and say, hey, Vincent, you know what? Can you modify the application to also do things like check whether there's there's salons for my wife too, right? It's not part of the requirements. The waterfall method, it's not a cycle method. It's basically a straightforward method. So you gather all the user requests and it forms your development cycle. So if the user wants to change everything, he's not going to change anything in between until when it's completed, right? Developers like this somehow, but of course they're not living in that world again. That's the only thing that form monolith. So it basically becomes everything is bundled together. That's just the word to use at the monolith. So for example, now consider a monolith. If you look at this point in 2, I say, hey, for example, consider a monolith e-commerce SaaS application. It might contain a web server, a load balancer, a catalog service that serves up product images in an ordering system, payment function, and a shipping component. All of them are bundled together. So, for example, if you look at this application now, this SaaS application now, right? It has a web server, it has a load balancer, it has a catalog service, it has a product, it has one that it has a an ordering system, a payment function, a shipping component. All of these guys are bundled together. So, if you want one thing about Monolith, if you want to make changes to the shipping, for example, now you have to bring the whole services down. That's how the world used to run before. These are talking like 15, 20 years back. That's how the world used to be run before. So you have to break the whole thing down. Compare that to compare that. I don't want to rush, but compare that to the one we're going to talk about, which is microservices. So that is basically what Monolith is about. See, okay, an application that is basically closely bundled, closely written together, bundled to work together. You cannot test different parts of the application without building all of them, without bringing all of them down. Most times they are written with tools like Java, Golang, all these applications that you have to compile them, right? Someone will say, hey, no, so does it mean that you can't use Java to write microservices? You can, right? I'm going to that. Contrast to monolithic, what we have now is microservices. Most people use now is microservices. Okay. Put in short, there are some cases whereby microservices is not good for you. But I'm going to drop that by the side now. Let's go with the modern architecture now is what microservices. Microservices say, hey, okay, I want to build my applications into small chunks. So there are, I think there are up to 1,000 programming languages, right? Right now, you can invent your own programming languages, right? We can tell now with AI applications now, Python is the bomb, right? If you want to do AI applications, the best programming language to use is Python, right? If you want to do web applications, animations is JavaScript, right? So if you want to do enterprise backend, is Java and Golang. With microservices, you are doing microservices differs from AI in the sense that differs from monolithic in the sense that you choose the language that is better. So, for example, now if I want to build the same application that I mentioned before, the e-commerce application now, I can decide, okay, hey, this e-commerce application now is going to have a shipping, going to have a payment system, it's going to have a backend, it's going to have several modules of this. We're going to build it into several modules using different languages. So it's called polyglot. So for example, now Vincent is an expert in JavaScript. Say, hey, Vincent, you build the front end, right? So part of the front end. Win is an expert in database, right? He's an expert in database. No DB, no SQL databases. Win will handle the images part that I want to store in a NoSQL database, right? Which other person? John is an expert in. Let me see. John is an expert in. John is an expert. Let me use for example. John is an expert in the backend database. I'll say, hey, John, write this backend database with Clever. So I can assemble this thing and use it to build my application. So what benefit? The benefit is that if I want to test the back end, only the back end, I might not need to touch the front end. How many of you have tried to use an application somehow that the application is up in the web, but some part of that application is not running? Maybe the shipping part of the application is not running. It used to happen there in Jumia. You will try to go buy things in Jumia, and maybe when you want to pay, it's giving you error. Why is it giving you error? It's giving you error because that part of the application is not available at the moment. Maybe I run testing. Maybe the endpoint is having issues, but that's just basically the issue, right? That's basically the thing. So how do you have to so how does the different modules of the application connect to each other? They connect to each other with what we call API, application programmable. Oh God, my Igbo asset is coming up. Programmable interface, right? That's basically how this application, this part of the application talks to this part of the application, they all connect together, right? So the beauty about it is that microservices enable you to hire I call them hire champions, right? You can hire the champion that fits that fits your application. It fits your category, it fits what you are looking to achieve. It fits your ideology. So for example, now I can say, okay, hey, I want to introduce AI models into my application. So I want my application to call let me say open AI backend. Right. What am I going to do? I'm going to write that part of the application that I want to make those call in Python. And the output can be passed into a React front end Sorry, it's totally possible, right? To explain it better, the last point here said an application programming interface is a set of programming calls that expose the functionality of application to developers, right? API makes it simpler to develop integrated applications by offering an easy way to pass credentials and data between applications. Think of it like this now. If I'm building an application in Nigeria now and I want to accept payments, I'm not going to go and start building my own payment from scratch. What am I going to do? I'm probably going to use the Paystack API, right? If I'm going to build, if I'm going to do shipping, I'm not going to, or let me use a simple, you're building a website now, you want to add a map to your website. You go and start building your own map from beginning. No, you just use Google API, right, to add your map. That's what the API is all about. So what are you doing? You are basically consuming other services. That is what it's all about, right? What's the difference between the two, right? Which one is better? Someone say, hey, why should I use monolith? Why should I microservices? It depends on what, right? When it comes to ease of implementation, to be honest, ease of implementation, monolith can be better. So, for example, if I'm an expert Java developer now, implementing monolith might be easier for me, right? But if I'm expert Java developer now and Win come and say, hey, wait, no, so I want to build an application for me and I write it with Java develop and I write it with Java, Win entire business model is now locked into me, right? So imagine that Win is building a website, an e-commerce app that launches. Let me use Ankara, right? Let me use Ankara Designs, right? Ankara Win comes and meets me. She's been a startup. Hey, no, so can you build this for me? And I go ahead and build it for her with monolith, Java front end, back end to end, and you build everything with JRE and everything. And what's happening? Tomorrow, Win doesn't like my face. Win cannot go easily because it means she has to go and build the whole stack of that application. Depending on the contract she signed, she might not be able to get to me. She might not be able to she will not be able to move really because everything is locked into me, right? I control end to end of our business. That's vendor locking. So do you want vendor locking? You want to do control and ownership of your data. For example, now some part of your application, it might be better with a NoSQL databases. So it might be better with a SQL database. Guys, how do you leverage all these services? You leverage them by what? Simply using what? Microservices, right? So microservices. So which one do you want to use? Whether you want to go to microservices or monolith, it basically depends on you. Return on investment. So microservices is difficult, to be honest. It's difficult to manage because you need experts. So you need experts on each domain, and it's difficult to also, for example, now it's also difficult to have someone. So for example, if you employ me as a solution architect now, and I'm architecting your application now, you're going to pay me a lot of money because it's my job to understand what happens in Python and in the JavaScript back and the React back end. It's my job to understand all this, right? Okay. Now we are done with monolith microservices. Sorry, guys. Any questions? Anything you're not clear about? Anything you want me to explain more?
So let me add up to what he has said. I think just to give you a simple understanding or a basic understanding, a monolith they are talking about is like one single unified system using and building everything. Imagine having to build all the application in one single unified program. And the microservices they are talking about is like, think of the word micro. Micro means small, right? Then services. We are talking about services that have to do with different services. So a microservice has to do with many. The microservice is talking about many small programs. That's what microservices actually mean. The monolith they are talking about is one unified system to use in building different application programs. And the microservices they are talking about is talking about something that has to do with small, many programs. So imagine the micro means small, and services you're talking about means too many programs. Services you're talking about one or more programs. So it means that microservice means they're talking about small, many programs. That's what it means. So a monolith is one unified single program used in building different applications, and why the microservice can build as much as you can. And the microservice is much more feasible in terms of monoliths. Monoliths, in terms of when you have too many programs, it fails at some point, right? And the microservice can help your programs to run smoothly in sense that you can manage them at any given point in time. So I think that's just the basics you need to understand the difference between a monolith and a microservice itself. Thank you.
Thank you. So then what is the DevOps, right? I'm pretty sure everyone in this room has heard this word DevOps. What is DevOps? DevOps. The DevOps is basically, hey, combination of dev and ops, right? And trust me, in the world we are today, this has evolved into several things. It has evolved. Like, can tell it has evolved. Like, for example, right now, I basically work as a platform engineer, right? I work as a platform engineer, and part of my role involves DevOps also, right? So, but to literally explain it is what dev and ops, that's what it's all about, right? Developers and operations. So in the olden days, developers and operations used to fight. I used to be part of that fight too. I used to be part of that fight because, hey, the developer writes his application. I mentioned it before. He writes his application in the system, does UAT finish, everything is fine. His manager is singing his praises. He reaches out to data center team, which is my team, and say, hey, data center team, please, can you guys provision a server for me to host, which is operations. We are operations, right? What do? We provision a server for the developer. The developer installs the application on his server, on a server, and tomorrow the application is having issues, probably because one library or something is missing, and the developer will say, hey, it's not me. I did a UAT, I did UAT testing, and everything was fine. Everything was fine in this application. Solomon, you tested it very well. John, you are there. Security, John, you are there. You tested it. Dominic, you are all there. Everything was working perfectly. Why is it not working now? Is your server. Me, operations, I will go ahead and open the system, check the network, check the disk usage. The disk is fine. I'll check the memory. The memory is fine. It's not spiking. The memory is maybe 30 or 40%. I'll check the CPU. The CPU is also fine. I checked whether this server started in the past 12 days, 24 hours as the application was hosted. No, right? So after checking all this, everything looks fine. Or from the server side, checking the logs, everything looks fine. I basically say, hey, this is not my problem. It's the developer problem. The developer basically say, it's my problem. It's not my problem. So because of this, it's happening in so many big companies, then that's why the DevOps come into place. The DevOps is all about, hey, merging developers and operations together, right? There's another one, DevSecOps, including security into it. So the whole idea is that, hey, okay, these two teams are no longer two different people. They are one person, all right? That they are one person or two people, but they are basically doing the same thing. So that's why you see most developers now, they can write CI/CD pipelines. It means, okay, how if I'm a DevOps engineer now, how do I help my developers? How do I help developers to achieve their goal? We're not two different teams now with two different managers touching each other. We are basically the same person. So typically, typically DevOps plans in the 4 areas of software development. Hey, planning, developing, releasing, and operating the software. So, for example, now remember, we want to build an application. What do? We plan. We plan the application, right? We plan. Remember what I said initially? I say you plan. Hey, I want an application that will cut my hair. Plan. Developing. The developer writes the application. Releasing. The application is released. Next thing, operating the application. So the fact that the developer finished the application and released it doesn't mean that the application is done. In the olden days, it means that everything that happens after there is basically the job of the ops team, right? But with DevOps, everything. Sorry, guys. Everything is synced together. So DevOps culture starts with what? Planning the goals of the project. What's the goal of this project? If I use this now, the goal of this project is say, hey, I want to get to barb my hair as fast as possible. I don't want to waste time. So, for example, what it means that, hey, I don't know whether some of you, I don't like coming to the salon and sitting down and wait for my turn. I want to come at the exact time and I want to cut my hair. So I need to be informed at the exact time. So in this application, now that's what forms the goal of this application. The goal of the application is to provide, to save me time in this sitting in the salon, right? Then it forms a high level, it will be what we call a peak. So at a high level, which is goal will be an AP. So the features, like, so what are the features of this application, right? For example, I want this application to be able to, like say, I want this application to be able to have things like, hey, send me text message. Don't show me develop the Baba with the least amount of time, right? Least amount of waiting period, right? So you can think of this in a hospital now. So for example, now if I hold it to a hospital application now, say, hey, I want a solution where I can bring up an app and show me the hospital that has the most space. I don't want to come to this hospital, there's no space, right? So that could be a goal of a feature of this application. But sorry, guys. Taking it back to this. So at the lower level, it's got features of the application. Then tax, how do I achieve this goal? So the tax might be, hey, okay, I'm giving author the the task of creating the infra for this application, right? It's basically that's what tax. The tax will be can be okay. Hey, I'm giving John the permission. I'm giving John the tax of building the front end of this application. I'm giving Stephen the tax of building the API calls, right? I'm giving someone the ability to build the payment gateway to do the integration. So this can be different tasks of this application, right? DevOps is a culture, right? It's not about tools. I would like to point this out, even though it's been ages. I know I believe most people know this, but DevOps is a culture. So one of the things about DevOps is the no blame culture, right? So we because to take it a step back, right? Everything in DevOps basically follows what we call application DevOps follows what we call I also call it a cycle process. So planning fits into developing fits into releasing the application, releasing fits into operating fits into planning again. So that means the culture of a DevOps is a cycle. It doesn't end. Throughout the life cycle of that application, so far as that my barbering salon application is available, it never ends. It means that tomorrow, so let's say tomorrow, at the end, remember when I said for monolith workflow method, you basically don't get to change during building. For DevOps, you basically say, hey, okay, hey, I'm going like this. And say, okay, initially it was built for only guys. Oh, I, 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 I want it to be for only women. Sorry, I want to include ladies in it also. It forms that part of that cycle. That cycle goes down again, goes down again. Since I'm building for women, so it means that what based on the output. So how many of us have looked at an application? This application, for example, I'll use our banking app for example now. Sometimes there are updates in the application. During the updates, is the feedback you give that is after when you're operating the app, the feedback forms under planning. That's basically the cycle of this. That's basically how this works. That's how the DevOps cycle means. And the beauty of that DevOps, it makes it an automated process. For the automated process, you can see is what we call continuous integration. Continuous integration is basically, hey, as you make a little change, so that change might be something a little about saying, hey, changing the color code during Christmas, for example, or during Valentine, for example, during Valentine, changing everything your word to red, for example. Now, when you change it to red, is basically continuous integration. It means that once you commit and release it, it tests it. So it's also doing automated. So, for example, now in the olden days, we not what's called UAT, whereby the developer might be dancing, doing. Sorry, guys. The developer might be dancing, doing whatever they want, doing nobody checkmates them. It's only when it comes to testing that actually we see what they are doing. In DevOps, testing is all the time. So the developer is doing his own commit, Git commit, is doing testing the application, testing it with all the security standards needed with SecOps, if SecOps is integrated, it's testing it with code scanning, for example, everything that is needed to make sure that testing it with sometimes testing it with the infra to see how would this even run on the website. So continuous integration is about an automated testing of the tool. So a developer is no more waiting till the end to deploy his application, right? You can promote root stages, but during his dev stage, he's actually doing the same testing he's likely to do during in prod. So testing is in the difference with DevOps is testing is introduced as early as possible. The other thing called continuous delivery, continuously delivering. So, for example, now Netflix. How many of us have Netflix? Most of us have heard on Netflix. Most of us have watched Netflix. Netflix say they push updates up to 1,000 updates every day. So I believe the engineering team is not up to 1 billion, right? How many people are in the world? But for them to push that 1,000 updates every day, releasing 1,000 things, updates every day, that means continuously they are testing, continuously they are deploying. And this is done in an automated way. To last point, see, finally, when a piece of software is running in production, the operations phase can start. So once you publish the application, the operations phase can start. So that the application is running doesn't mean that it's done. Most of us have visited a website or application that is very, very slow. This app is very slow. It's also part of DevOps. It's part of DevOps for you to part of DevOps that does that is basically called site reliability engineering, SRE. So you are monitoring how the user behaviors. So, for example, if I build a website now that let me say if I build a website now that help people to buy let me use it for help people to buy Bitcoin. All right. Now notice that this is my website now. People visit 1,000 people visit my website. But at the end of the day, I'm only getting 10 people to buy Bitcoin. How do I know what their user experience is like? How do I know what is wrong? Why they already know that nonso.com sells Bitcoin? Why is that when they come with the intention of buying Bitcoin, they're not buying Bitcoin? What's the user experience back? That's where the operations thing comes in. Since it comes in because it's on, hey, you are actually checking the application, checking the user, checking what we call user flow, spans. If a user visits noto.com, okay, he visits where does where does the user go? And trust me, all applications does this. That's why sometimes you go to Jumia, you have things in your cart. You go to Amazon, you have things in your cart. The next day, Amazon say, hey, you still have something in your cart, or come and buy. How are they doing that? There is automated process monitoring what you do on your website, where the pitfalls are. That's how you do. That's how you get conversion. So unlike the olden days, whereby once you go to the application is there. It's no more your problem. Here, the operation part involves maintaining feedback. That's why most times after buying things from most e-commerce websites, they'll say, hey, how's the user experience? Were you happy? Is there things you're missing? Is there things you want to add more? Right? Can we help you? How was your user experience? That's DevOps. So I think I mentioned they say, hey, DevOps process is basically iterative, right? A single team is never in charge of all the process. No team is in charge of all the process. It flows from here to here. And the beauty about DevOps is the no blame culture. I really have to point this out. Sure. So the idea of DevOps is that nobody gets blamed. Things go wrong. Rather, we're looking at why did those things go wrong? Can we mitigate against it? Right? That's DevOps in a nutshell. When it comes to that, there are multiple tools for DevOps, right? There are multiple tools. There are Jenkins for your CI/CD. There is Azure DevOps. There is GitHub, right? There is Jira for planning, right? You can use any of those tools. It doesn't really matter. So that's why I said DevOps is not about tools. It's about a culture, the culture of doing things, right? Now we're entering into Docker, right? Docker. Any questions, guys? Any questions? Any questions? Anything? Am I talking too fast? Would you like me to slow down?
So
Am
I
I?
can just chip in. I
Sure.
can just quickly chip in the better understanding of DevOps, right? The DevOps that
Yeah.
you all know. Let me just add up to what he has said. The DevOps we are talking about is the DevOps is dev are the people who write the software itself, and while the ops, which is the operations, are the people who run the software, deploy the software, and maintain the software. So it's a win-win for both the developer side of things and the operational side of things. There is no blame game in the DevOps culture or environment. It means that in the olden days that you people that they are solving issues and then something happened, we don't know where the fault is coming from. Somebody will say, hey, it is not from the development team, it's the security team. Meets the architecture team, so there is no blame game. In the DevOps, things becomes faster, easier, and then you'll be able to point out where the fault is coming from. So it's a combination of a developer side and the development side of IT and also the operational side of it come together to form DevOps. So in a simple term, it is very easy to understand that the dev are the people who write the software, and the ops, which are the operations, are the people who run the software, and as well, I'll put it this way, run the software, deploy the software, and then maintain the software, because it is a life cycle. Remember, the DevOps is a loop that runs continuously in that routine. It doesn't stop. It goes from test, build, deploy, monitor, improve, and then go back again to plan. That's the routine. It doesn't stop. It's the loop that continues to run over and over again, right? So in a simple term, people who run the software and people who manage and maintain the software forms the developer operations, which is called the DevOps. Thank you so much.
Thank you. Okay, so the next thing I'm going to talk about is Docker, right? What is Docker? What is Docker containers? What are they about, right? So think of it like this, right? Docker. It's okay. So when you have a question, go ahead.
Okay, my question is about the DevOps. So we have
Okay.
the development side and we have the operation side. If
Yeah.
I'm correct, are there two different departments? So the people that develop the application or the software are different from the people that deploy the software. And and it means that the people that deploy the software should have like in-depth knowledge of the software development.
I like
It's
your
yeah, I
question.
don't know,
I,
it's kind of complicated,
it's got complicated. I like how you're thinking. I am thinking, and you're like thinking, what is now different to the way we are used to do it before. So
yeah.
that's why I say first of all, DevOps is a culture, right? So if I take it back now, so I'm a DevOps engineer, right? You are a developer. Let me say, for example, you're a React engineer, right? You guys are writing the applications that we do, this building application that we discussed. Part of my job is to make sure that hey, I provide an environment for you. That might be a Git repo. I help you write the pipelines for your application, CI pipelines, integration pipelines, and CD pipelines, development related that such that when you do a Git add means you are committing your code, you're committing your code to the repo. All those tests that you normally run locally, you are doing it on on a pipeline on a DevOps server on our Azure DevOps or on Jenkins. So I provide a platform for developers to run their application. So I might not know what line 49 or 54 does in your code, right? But I'm pretty sure I understand that the application runs on port 8080 or 8051. I understand the end of your application. So we might be two different teams, but we are working hand to hand because we have the common goal, which is developing, deploying, and maintaining this application. So, for example, now, if the website is become slow, right, and I check through my monitoring tool, I'm seeing that hey, it's because of a SQL code that your application is running that is doing what that is fetching more than it should. It forms a tax for me to come back to you and say, hey, Win, as a developer, Win, I need you to update this. This is a tax for you. This is what we notice while operating this application. Right? You get what I'm saying? So I might be, I'm being ops, DevOps means I provide the platform. I understand everything about the application. I might not understand the code. So, for example, now, hey, you can say I understand Dominic very well, but I don't know his house address. The particular place he lives in Lagos. That's the difference between it, right? I know Dominic is a DevOps engineer. We've known each other since 2017. Blah 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 blah. I know he's very good in Terraform. He's good in Python. He's good in YAML. He's good in Kubernetes. He's good in Argo CD. Henry, I'm coming in a second. Let me just stand up. I don't understand. I understand those parts. I understand what he's capable of, but I might not know the specific details. I might not know the name of his child. Right? That that DevOps. That's the DevOps part in a nutshell. Is it clear?
So
Yeah, I
so
understand. Thank you.
so in a simple term, if they are in the same department, it depends on the organization, right? Meaning it depends on the
Yeah.
DevOps is not always a separate department. In a modern, like in a modern settings, I'll put it that way, on a modern company, it should not be, right? So the
Exactly.
traditional company structure can be DevOps build the software, the operations manage, deploys, and run the software. They work independently. You should know that they work independently, and which are but previously it causes problems like slowness in releases, miscommunication, blame game that comes in from different side of things. So what he is trying to tell you in the sense that DevOps is a way of working, not just a team. It's a way of working, a core idea. It's an idea like developers and operations shares responsibility for delivering and then running software together. Because of this, DevOps can be structured in different ways. What he is trying to explain to you right now is it's a culture. It's not statistically that they are in different departments. No, they should not be. What he is trying to tell you that it is a culture that there is no job that work as a team, not just as a team, an idea that works together. There is no blame game. There is no say, hey, you are the one who caused this problem. You are the one who put us in this mess, and you have to fix it. No. So it's easy to track failures, releases, slowness. The essence of DevOps is just to help you make things become faster and then easy to work with. In the olden days, they are building software, they are finding issues, faults, and it will take them hours, days, months to solve one simple problem. But with the help of DevOps, that comes together and work as they come together and work as a culture. It means that things can be easy, can be solved easily at a given point in time with just with just one command. The whole thing can run smoothly and everybody will go and sleep. So what he's trying to tell you that it is a culture. It is not a team that is segmented. No, we understand it is DevOps, developer and operation. It's what he is trying to tell you. It is a culture. It is an idea that comes together and bring up that that culture that works. I don't know if that answers the question.
Yeah, it does. Thank you so much.
Harry, please go ahead with your question.
Okay, good evening, everyone. I get the idea that DevOps it's a joint work, not different from the development and operation. Okay, like from what I understand, what this security personnel does in DevOps is to take care of the security of the application and maintain the scalability process of the application. So how do you do this if you have a zero coding knowledge? That's what I just want to understand.
Very good. Okay, so you mentioned security now. The aspect of DevOps is that involves security is what DevSecOps. Security into ops, right? So DevSecOps is a part whereby, hey, security people we also bring in their own platform, their own tools. Like for example, let me use for example code scanning tool, like Defender for DevOps, or what's that popular one again? Maybe you can remind me. Will be integrated as part of the CI pipeline. Remember the CI pipeline, the continuous integration pipeline is what once developer does commit, it tests everything, make sure that the application is make sure okay, for example, now we are going to go into containers very soon, but if you are using a base image that has vulnerability, security has to be involved at the very beginning. So that's where all get back to DevSecOps. So a security guy, that's why being security now doesn't mean that you will just say, hey, okay, 443 is blocked, is allowed, 443 is allowed. That you have to be technically good. The same way we up in the olden days, we don't used to write code. I don't use to write code in the olden days. Now I write Python, I write pipeline, which is YAML, which is coding, to help the automated process. Is all part of DevOps. So DevOps culture has moved beyond say, hey, okay, this guy writes all my code. This guy does all my deployments. This guy does take security signs off. Security is now involved on a day-to-day process. If your application is going to contact some registry, let's say, for example, it's going to fetch Google API. In our environment, we allow applications to go and get Google API. Are we comfortable giving Google our data? For example, if you're developing for Europe, there's what we call GDPR. Are you comfortable developing for giving Google that data? Right? If you're developing in Nigeria now, one of the things they will ask you is, hey, where is the data stored? You have to personal information should be stored in data in Nigeria. Those are the things that security comes into. They are involved in the very beginning. So being into security now, again, this is different from company to company. Being into enterprise security now doesn't just mean that you are just your hands off. You're only waiting for when the application is deployed. You are involved from the very beginning. You are involved in things around code scanning, vulnerability scanning, right from when the developer is developing the applications, right? You're not waiting till the very end. And all the 90% of this, basically 100% of this will be through automated processes. You have processes in place that does hit scanning. For example, there's Microsoft Defender for DevOps. That's my organization now. Right now, we set it up in our Azure DevOps repo, our Azure DevOps organization. That whenever any developer commits any code, automatically start scanning that code for vulnerability. So that is the process these days. The process these days is that things are moved from manual process to automated process that everybody write code. You might not be writing the application code, but you are likely writing the code that is used to automate the deployment process. Is it clear?
Okay, yeah, it's clear. Why I'm asking this is
Actually
that
clear.
yes, what is because there
Go
was a
ahead.
time I was this CI/CD pipeline something, and I scanned the code and it was telling me that line something doesn't have a parameter and all those stuff. And if you don't understand code, you won't actually understand what it's talking about, like what you need
Yes.
to fix that.
So
That was why I asked the no
so
code question.
so that's why it's it's impossible to, I won't say it's possible. That's why if you see more job roles now, they can say, hey, entry level Python. They'll say Python knowledge. It doesn't mean that every day you are writing Python backend, but I expect you to understand the basics of what that code is doing. So if a code is throwing a particular error, you expect it to understand why it's happening that error, why that error is happening. Sometimes if you're an SRE for the start level engineer, you're expected to even troubleshoot the code, right? To troubleshoot the code. Necessarily you work odd hours. If you're on call, that means you're working during the night. You're on call during the night. What happens during that time? You notice that something is bad. It's not working. Something is not working. You're not going to wake up the developer. You have to troubleshoot to be able to get the developer the right method. So, for example, now let's say you are running a pipeline. A pipeline gives you error, and you don't know line 54, for example, parameter means that you're missing something that is expected to pass in a value. You didn't pass in that value. So you should have I call it programming knowledge with the AI knowledge, with AI now, rise of chatbots and copilot and cloud, you can actually write code, but need to have that development knowledge. You need to have that understanding. It's not that difficult. You just need to understand how things work. Right. That's why I need to start this by telling you, okay, hey, Docker this, these are the commands to run Docker. We started this class by basically explaining the whole processes, right? Explaining the whole process. So if you understand that, if it errors out, you understand why it's happening. You understand why it's happening and basically forms basic of what you're doing. So for example, if you are doing a pipeline now, you can do a pipeline that deploys the application and security will tell you, hey, this application, you need to add code scanning to it. You need to know that it's just actually a task that you need to add a task in your pipeline, right? Depending on code scanning you are using. Okay. All right.
All right, thank you.
Okay. Any questions? Any more questions? Okay. All right. You can bring your hand down. So I think somebody dropped in chat. Okay, let me see. Okay, nobody. All right. So now we're going to containers, right? What are Docker containers? So what is one container? So we want to say, okay, hey, no. So what is container? First of all, container simply is a lightweight application. That's the way I see it. So remember when I said in the olden days, people are asking for servers, and when they host their application, they'll say, hey, this application is working well on my laptop. It's not working well on the server. To mitigate that, containers came into place. Container is a way for you to package an application. I built an application for Steven. I want a way that Steven will just carry this application, go and run it anywhere in the world. What do I need to do? I need to package it as what is a container, right? The de facto one is Docker. Docker is the most popular container. It doesn't mean that there's only Docker. There is Podman, there is LXC, there are other container images, right? But the popular one is what is Docker. Such that even you will see the container images are more called Docker files. It's called Docker file because it is the popular container image. I'm going to as per 2018, 3.5 million applications have been containerized. This like I'm sure this one application containerized are running to billions now. So if you're writing applications now, likely, so for example, if I'm writing an application I want to share with the whole world now, I want to share with Dominic, for example, now, and I need to package the application so that you do have all the necessary libraries, everything that you will need to run. So Dominic doesn't need to install anything. He just needs to run the image. It will pull all the dependencies and run. That is what a container is all about, right? Easy way to package the application. If we dig more deep into Docker now, Docker components, Docker engine is the core of Docker solution. So for example, now, I would advise you at the end of this class for you to go and download Docker Desktop in your system, so because it will really help you to practice some of the things we're preaching, right? Docker engine, the core of solution, it's basically client server. You make calls to it cleans up what you want to do. Docker CLI, Docker clients is a CLI too. How do you say, hey, I want this image, I want this particular, I want to build this particular application, I want to build this particular image, you usually click Docker CLI. The Docker host runs as a daemon on your desktop. That means it's basically listening for this. I'm going to show you an example of this, even though I know we are closing next 25 minutes, but I'm going to show you an example just before I close. I'm going to show you an example of Docker desktop, right? Docker registry. Docker registry is basically a store where your images are stored, right? What is a Docker image? I believe it will be in the next slide. But to go back to this, Docker registry is basically a repository where your images are stored. If you want to store your images, you want to store, if you build an application now, for example, like, hey, I build a Docker image, I have a Docker image now. I want it to be available for everybody to access it. I don't want to, does it mean I have to be copying the image to everybody? No, I need to post it to a repository. That repository can be example can be what? Docker Hub is an example of a repository. For private ones, there's Azure Container Registry. There is I think Amazon Container Registry also, right? No, I think Amazon Container Registry. So that's another example. So if I want to share an image throughout the whole world, it makes no sense for me to publish it to what? To Docker Hub, right? A Docker image was a read-only template used to build Docker containers. It might be tricky, but try to understand this, guys. An image, I can show you an example of a Docker image. I have one running here. I will bring it up in a second. Yes. This is a Docker image. This is an example of a Docker image. Don't think of it, nothing too complex about it. Just, hey, this guy builds an image. So far like this is just basically read-only. It's not doing anything. It only starts doing anything when I run it. So if it starts running, it becomes what? A Docker container. Guys, am I making sense? A Docker image, basically, if you look at this in detail, I believe the next slide will explain it, not the next slide. Okay, I'm going to come to where that shows you the difference, what actually a Docker image actually basically does, right? It's basically a line-by-line process of what is happening in the application. What exactly are happening in the application? What do you want it to do? It does line by line. So I can say, okay, I want to use this base image. I want to use this. I want to use this. That's basically what a Docker image is all about. So if I download that image, if I pull that image and start running it now, it becomes what? A Docker container. Right? Okay. Docker is available in 2 editions. Oh, sorry, guys. There's a community edition and there's the enterprise edition. Focusing on Docker a little bit, let's talk about containers versus virtual machines. So don't ask me also, hey, VMs are also used to package applications. What is the difference between those two guys? The major difference between the two is that for a virtual machine, you need what we call a hypervisor. Right, guys, remember the guys that joined us this last year, you remember when we talked about virtual machines and hypervisors, right? We talk about using the open source zone, right? We also talked about why the VM sorry, I keep forgetting. Keep skipping my head. We talked about the different ones, right? So you virtualize. So for example, your laptop now you can have multiple VMs running on them by installing what a hypervisor. You can use VirtualBox to install it. You can use, some people use paid ones to install it, so you can use any of the VMware, you can use any of that. You can use VirtualBox, you can use any of that, right? So that's basically VMs. Docker containers, on the other hand, doesn't need a hypervisor. Doesn't need it. The difference is that for containers makes use of. So if I have VM1, I can have a VM running Linux operating system now, right? Another VM running Windows, let's say Ubuntu in my same laptop running Ubuntu, I can have an VM running Windows Server 2022, right? These two guys does not know that they're coming from the same laptop. There's complete isolation between the two. They can ping each other if you permit the IP address, but they run independently of each other. That is VMs. When it comes to containers, on the other hand, containers make use of libraries. So if I want to run a Linux container now, the operating system must be a Linux operating system. Very important. Just it's important to know this, that if you want to run a Linux library, the operating system must be what? A Linux operating system. Because what? Containers make use of the operating system libraries. It's very important. So example of a VMs will be like, hey, you install the Azure desktop and you instead of VMware, configure it, and you can set up multiple systems. A container, on the other hand, if you want to install a container, you basically ask you, hey, okay, if it's Windows container, it has to be a Windows operating system. If it's Linux container, you might need to install a VMware, a Linux operating system first, then you can run a container from there. That's the kind of difference between the two. That's why if you are installing Docker Desktop, likely it's going to ask you, hey, you say, hey, Oga, I want to set up because hey, Oga, I want to set up WSL. That's part of the thing it's going to ask you because it needs that Linux libraries to be able to execute efficiently. All right. More into containers. Containers are still a form of visualization, but only visualize what is core in running an application. Okay. Piper said I should explain the Linux library and Linux path again. I think it's very good that we are in this page when we're talking about that. The explanation there is to note like this. For example, now there's what we call when it comes to containers, that's what we call Windows containers and Linux containers. Why is that so? In Windows, in visualization, it doesn't care whether it's Windows or Linux. It doesn't care, right? So, for example, your laptop can be running on Windows. You can spin up VMs that are running on Linux to work efficiently. If your laptop is running on Windows and you want to spin up a Linux operating system, it will need a Linux host somehow in your system to be able to put that library. Even because containers is not a complete virtualization, it virtualizes only a bit part of it. Because containers still go to the operating system to pull up libraries. That's why when we get to WCAST now, if you plan to host Windows containers, you need to host a node that has Windows operating system running on them. So say Solomon asked a question. Say, is Linux a required skill set for Kubernetes? Yes, you have to know Linux. It makes sense to know Linux because there are GUIs to deploy, but most of the things you will be running is you are running kubectl, you're running command line, you're troubleshooting, you are doing exec into a pod, you are doing exec into a container to check what is wrong. Yes, Linux is very important. So it makes sense to know the basics of Linux. Piper, did I answer your question?
Yes, you did. Thank you very much.
All right, you're welcome. All right, so another difference between containers and VMs is that containers basically are lightweight. They boot faster. For example, you can see containers that are small as 100 meg, 50 meg, depending on your base image. Caveat, based on base image, containers are actually lightweight. In containers, some of the underlying components are shared across. That means if a container running on my laptop can test other containers running on the same laptop, it's totally possible because they share the resources of the host. In VMs, they share the resources of the host, but they don't know. There's complete isolation, right? Okay. Someone asked a question, say, what's the difference between a Docker, Kubernetes, and Docker container and Docker image? Okay. Let me explain. A Docker image, first of all, is what? A Docker image, first of all, if I go back to this, let me just go back to this a little bit to explain. Yes. Docker image is a read-only template. It contains instructions of what the container should do. It's like giving you a manual. Once you start implementing that manual, it becomes what? A container. So a container is becoming what? A running image. So for example, now, if I should bring out this screen I showed you guys before, this is an example of a Docker image. So if you look at the first line, I don't know whether, is it too small? How do you zoom in oh God. How do you zoom in again in VS Code? This is something I'm working on. But I need to show you guys this. Let me see. Okay, this is the labs. Let me see whether I can show example of a Docker image. Yeah, okay, this is an example of a Docker image. Can you guys see this one very well? You see the path. This guy is an example of a Docker image, right? He's saying from Python this, as it is now, copy app, put it in working directly, do pip install flag, expose to port 5000, run this command, run this. This guy is a Docker image. He follows a step-by-step instruction. This is a Docker image. But right now, it's still an image. Until it starts running, it's still an image. Right? Still an image. When this guy starts running, it becomes what? A container. It becomes what? A container. So that's why I say a container is what? A running image. So looking at this now is basically, it's just like basic instruction. Say, hey, from means I should go to Docker Hub and copy and get what? This container, this image. Python, use the Alpine version 3.7. I should copy what? Copy the everything in dot directory. That's why I say, hey, Solomon, thank you for that question. That Linux is very important. Copy everything in the root directory and what put it what in app. And say the working directory should do /app. I want you to run this command, means install this, pip install Flask. Okay, this is my application. How do I access which port is it exposed to? I want to expose it to port 5000. It's going to expose to port 5000. Then the next is going to do, okay, hey, command run python.py, run the Python application, is going to run it. Right? This guy is it. This guy is it. Right? This guy is basically, this is the Docker image, step-by-step process of what's going to run. Container is basically what? A running image. Kubernetes, on the other hand, you are pushing me forward a little bit, but I'm going to explain it now. Kubernetes, on the other hand, is basically what Kubernetes does. Kubernetes helps you to manage different containers. So, for example, now, hey, when we do the labs, you'll see, I'm going to get to the day, but when we do the lab, you'll see, okay, you have a container running. If you run a container image now, you can only run one container at a time. Imagine now, imagine what I talk about microservices. Say, somebody build the shipping, somebody build the ordering, somebody builds the front end, someone builds the middleware and everything. Different containers, right? If you run them, but they are running single. Kubernetes' job is to orchestrate, basically manage all those containers. That's what Kubernetes is all about. It's just orchestrating of containers. It's going to make sure, Kubernetes how this thing they say is self-healing, but what that means actually basically means is looking at a container. If a container fails, you will try to restart it, to try to bring it back online without somebody manually going there to do it. That's the whole Kubernetes self-healing. Very, very beautiful tool, right? So that's the difference. Kubernetes manages containers. It's used for container orchestration. It's not just Kubernetes. There are other ones that, for example, Swarm does that. Nomad does that, right? There are other things that does orchestration, but Kubernetes is the most popular one.
Okay, so,
okay.
So you can run Docker without having a Kubernetes running too.
You can run a Docker image, a single Docker image, okay. Right? You can run a single Docker image. For example, if I build my application now, the application I built the API application the AI application I built, I'm testing with, it's running what a single Docker. I'm running on Docker because it's not easy. But if I want to deploy if I want to expose it now to the whole world, I can decide, okay, hey, let me pick up only this image and set it up on a VM and expose it. It can be run on live VM. But if I want to add orchestration, if I want to figure out if this container fails, I want something to bring it up. I want something to restart it. I want to make sure that it has the right integration with the resources. It makes sense to use what? Kubernetes. Some people use Docker Swarm, but Kubernetes is the most popular one. Okay, guys, are you still following? Class is quiet.
Yes, yes.
Okay. All right.
Yeah, sure.
Yeah, moving forward a little bit. So the difference between containers and image and virtual machines in a form of an image, right? A container basically see containers, the physical server, there's an operating system. This is Docker engine, basically making use of the things you have here. Application libraries, they still make these libraries are actually coming from the operating system. In terms of virtual machine, there's clear isolation, right? There's guest OS, there's libraries, there's application. See how containers doesn't have their own guest OS, basically making use of basically making use of the OS of the making use of the OS of the operating of the server that they are running on, right? They don't have their own separate OS. So Solomon, you are too fast, but this is kind of the question you are asking. What are images? What are images and containers? An image is what? A set of commands in a file named Docker file that defines the environment inside a container. An image is a package or a template, just like a VM template. It's used to create one or more containers. Containers are running instances of images that are isolated and have their own environment and set of processes. Images are read-only. Containers can be modified with changes, but those changes are lost when the container stops. That's why you need Kubernetes. So containers are what we call the ephemeral. So anytime a container stops and starts again, it's pulling the image. It's starting like a new baby. Just the best way to explain it. How many of us have watched that movie whereby a guy wakes up in the morning and starts going through the whole process again? That's basically how containers are, right? Containers are as a ephemeral. So anytime a container starts, it's starting like a brand new system. So if you want to be able to say, okay, hey, I want you to see reference some previous data, that's why you need things like storage, you need to include storage, you need to attach storage to it. That's where all those things come into it. That Docker images get a unique ID by default, but can be named or tagged, right? Docker networking components. I'm going to round off here because I don't want to enter into, or maybe I can get to Docker. I'll talk about Docker installation so that by next week we'll start again. I don't want to drag the class too long. Docker components, networking. When it comes to networking in Docker, there are three types of networking. There is bridge. This is the default. It means that if I create a container in my system, right? The container can access my systems. It can access my system. It can access with other resources within my system. That's bridge. Basically, when Docker starts, a bridge network is created and the container will be connected to the network unless otherwise specified. So automatically connects to, it can connect to other things within my network, right? That's a bridge network, like a bridge. The next one is host. I can say, hey, okay, if I create a container, I want to be isolated only to my system, only to my laptop, for example. I don't want it to go beyond my laptop. And I want it, so if you are from another laptop, let's say, for example, people bring their own laptop and connect to in my own network, they will not be able to access that container. That's host only. I configure it to only be accessible from my own personal laptop. The next is overlay, right? Overlay is basically for multi-network. Basically, it has its own network. It does some sort of nothing. That's basically what it does. It basically does a network abstraction outside of the network or your physical network. So, for example, in bridge, it can pick up IP address from your router. In bridge networking, it can pick up IP address from your router and become part of like that. You go to your router, you'll see it running as an IP address. In overlay, it has its own separate network outside of your router, outside of your environment, right? To see like it creates like some kind of VPN device to feed itself outside of your network. That's what overlay is all about. There is Mac VLAN. That's basically you are connecting with MAC address. This is rarely used, so I just put it there so people will know. There's also NATs or port mapping that those ones are really used, so I'm just put it there. Maybe at the end of this whole slides, I'm going to share these slides, turn it to PDF and share so people can, if you want to go over this. Although most of this, to be honest, you can learn them through the internet. So the idea of this is to open your eyes. Okay, hey, these are available. When you go to Gemini, ChatGPT, you're asking questions, it explains to you to make more sense. All right. Docker storage. So remember when I say, hey, whenever a Docker container starts, it's looking like a newborn baby. It doesn't remember anything. So imagine that I'm building a database now. My database is in a container, and I have Favor registered, I have Leo registered, I have Vincent registered, and somehow the container gets restarted. It means that every user in the application, they have to come and register again. Imagine you come to a website, you register today, tomorrow they ask you to register again. Every time you come, they ask you to register. That's what a container is by default. So, but if you want to extend it to use, you want to run a database on them, for example, you have to attach a storage for it. So that when the application comes up, when the Docker container comes up, it goes and picks those, it maps to that storage. This guy maps to his data, and that's what called data volumes, right? So remember, container by default is ephemeral. So it goes and it comes and goes, right? It comes up, it goes. That's actually one of the things that makes it beautiful. So one of the things that will tell you that, hey, it makes sense to host stateless applications on containers. What I mean by stateless means application that doesn't have, I don't care about data of those applications. If you want to host stateful applications, for example, now, but you have to attach what volumes to them. You have to attach a drive or a disk to them. That's what it's all about. Okay, this is Docker installation. How do you install Docker? I'm going to stop here and just take questions because we have just 4 minutes till 7:30. So I'm going to stop here and take questions. So next week we're going to start from here. Next week 6 p.m. we're going to start from here again, because I don't want I don't want us to rush this. I want us to take them and understand it. But during the week, what you can do is download Docker Desktop. I'm going to put the link here. Download Docker Desktop, install it on your system, have a feel of it. Having a feel of it. So by next week, we can also do labs and tests. So when I'm doing labs and tests, you can actually do it alongside me. So I'm not doing magic, right? You won't say, yeah, this guy they do magic. No, right? I'm going to share it on the link, so go ahead and download it, because if you're staying in Nigeria and that is an issue, that's why I'm putting it here, because I think it's around 550 something gig, right? It makes sense to download it, have it on your system, so that you can practice. There's a URL where you can practice, but you can also practice locally on your laptop, especially if you have up to 8 gig or 16 gig. Right. Okay. So Dominic is also saying the next class is going to show us how to do the sample Python app. So after the club, so what I'm going to do is we have 1 hour 30 minutes every class. And maybe in the first 1 hour we'll use it for slides and discussion, and then we'll use the next 30 minutes to do what build images. Okay. All right, guys. Any questions? Any questions? I can take a few questions just before we round up. Any questions? It doesn't have to be on Docker Kubernetes. Any questions you have, you can just ask. Henry, go ahead.
Okay, please. My question is just simple. As a professional DevSecOps person, would you advise us to get this Docker setup on a Windows desktop system or a Linux operating system?
Windows. So set up on Windows. If you have a Windows laptop, which I believe most people are using Windows, have it running on your Windows. You just need to set up WSL. You need to set up WSL on your system. WSL. So, for example, now I'm using a Windows laptop and I have it set up. For example, this is me now. These are all the images I actually have running. And the beauty about Docker Desktop, you can set up Kubernetes on it, right? So that's also one of the reasons why I actually want you guys to do it. So, for example, if you go to Kubernetes context, you can. This is Kubernetes. I have Kubernetes running on it. You can set up Kubernetes on it. That's why I really want you guys to have it. Download Docker. Like, these are all the images for example, some 4 days ago, you can literally see it. These are the images I have. I published. These are the images I have. So you can have it. So please, if you are using Windows, I don't want you to start formatting your system using Linux. It will help you to not killed, right? But you can use it on Windows. Just make sure you have WSL. Windows subs is basically Linux or Windows. You have WSL running. For example, now my own WSL, I have Ubuntu running on them. I can bring it up local. This is the Windows system, but it's running Ubuntu. It's running Ubuntu. See, it's running Ubuntu. So that's WSL. Just set that up. That works for you.
Okay, thank you.
All right. Okay. Henry, do you have any question?
Sorry, I just asked my question. Let me raise my hand down.
Okay. All right. Solomon, any questions? Sorry. Fixing your hand is raised.
Yeah. So thank you. Good evening from here. So
Yeah.
my question is, like, can you properly learn Kubernetes without knowing DevOps? You understand? I don't know how DevOps works, but I just want to learn Kubernetes. And also, I need your advice on the current market. Like I don't know about any other person. My own goal is to get a job and get the skill, then be marketable so that I can get employment in regards to that. So, sorry. So my network is.
Okay. Yeah, the network is breaking. I thought someone else was speaking in the background. Okay. All right. Piper, I'll answer your question in a second. Yeah. Thank you very much. Yeah. So Solomon, Kubernetes. So DevOps is just a tool. DevOps is not a tool. It's a culture. So, for example, now I've worked in companies that do DevOps, but I don't do Kubernetes on a day-to-day basis, right? I don't do Kubernetes on a day-to-day basis. When I moved to the Netherlands, the first company I work with is one of the largest bank in the whole of Europe, maybe an AMRO. I do DevOps in the but I don't do Kubernetes. So Kubernetes is actually different, right? Is a tool under DevOps. Is a tool for you to use to host containers. So, for example, the idea of me teaching you Kubernetes is if you go to a company now and they're using Nomad or they're using OpenShift, OpenShift is still based on Kubernetes, right? If you go to a company now, they are using Nomad or they are using something different. But the fact that you already have Kubernetes, what does Kubernetes do? Container orchestration. The fact you already understand Docker, building image. So if you come to a company that are using Podman instead of Docker, you're not worried because you already understand the basics. Kubernetes is all about CI pipelines to commit to repo, pipelines to make sure that pipelines to run here, pipelines to run here. That means somebody can actually come and see what you do because there's a pipeline that showed what you did. You're not doing magic, right? That's what it's all about. If you can't do DevOps without Kubernetes, for most companies hosting their applications on Kubernetes is replacing the language of the internet. For example, now if you check most AI jobs, they're talking about, training model. Next thing tell you, okay, do you know Fast API? They now ask you, do you know a little bit about Kubernetes? Because the application you are going to, AI model you are going to train is likely hosted on Kubernetes. You should be able to, quote unquote, connect to the container, restart the container, right? You should be able to do that. You should be able to understand the basic commands. You should even if you push your image and it gets hosted in you, need to be able to open that. That's basically the whole Kubernetes is all about. So that is what it's all about, right? So it's not most like if you check now, there's some DevOps role that will not even mention Kubernetes. They'll mention things around Terraform for IAC. They mention things around Bicep for IAC. They may mention integration, right? They're not talking about Kubernetes because they're not using Kubernetes in their environment. I know some companies that move from Kubernetes back to servers, right? They're not using Kubernetes. Example, Amazon Prime. The company I'm working with now, I'm working as a platform engineer, NIBC. NIBC is a bank that is up to 80 years in Netherlands. They are not using Kubernetes. They have only one Kubernetes environment. Every other thing we're running it on function apps and web apps. So they decide to do that. We have dealt with function app and web apps when we did our AZ104. So again, this is actually the next level because some jobs will require you to know Kubernetes. So this is the job to introduce you to Kubernetes, to show you more on Azure Kubernetes, what you can do with Azure Kubernetes, and what it's all about. So you will not be seeing it as one big thing that nobody else can touch. I expect it's actually very simple. In my system now, I have Kubernetes environments running. Okay. Piper, WSL is sort of Windows Windows Sub Linux. I think I'm probably missing the pronunciation, but it's actually a way Microsoft made a way for you to install Linux on your Windows 10 and Windows 11. So you can choose your operating system. In my case, I choose Ubuntu. You can install it running on your system and you can practice Linux. For example, now the Linux commands run here. I can run ls here. I can run several things I want to run. If I want PWD, the Linux commands run there. So it's like almost like a full Linux system running on your Windows 11, Windows 11 or Windows 10 GUI. Very, very sweet too. Actually love it very well. Okay, Favor, you raised your hand. Please go ahead.
Yeah. Good evening, sir, and
Good
Happy New
evening.
Year.
Happy New Year.
Thank you. Thank you for the class. It's very, very insightful. So, for us that are learning Kubernetes for DevSecOps, I was wondering if you have any other security-related resources that you can share as well. So, to be very easy for us.
Okay, so I can check and share for you because I'm preparing to write. I want to do Kubestronaut. Kubestronaut is the certification for if you write 5 Kubernetes certification, they call you Kubestronauts and give you one jacket. And part of the thing is Kubernetes security. And one of the things they do, one of the things in those classes is that in those courses they deep more into how to secure Kubernetes cluster. So, for example, Kubernetes we are running, you're going to run this class. It's going to be like basic ones. We are not going to, I'm going to show you how to secure it. For example, you don't want people to your API to be available over the internet. I'm going to share something like that to you. And hopefully helps you. I can also share a code, share a video on WCAST, but it might be too deep for you. Now, I will say focus on. You can just do it to understand the. I'll say do it to understand the basic knowledge. So, for example, now part of the things you do if I set up a Kubernetes environment, part of the things I would do in an enterprise environment is to make sure that nobody execs into the host. So, for example, now hey, Kubernetes is running on Noso system. I don't want you to be able to log into the container and be able to connect to my system. But if it's my lab environment, I don't care. So those are part of the security standards, right? So there's things about pod security, who should have access, what should have access to your cluster. All those things are part of Kubernetes security. I will look for a documentation and share for you. I'll look at the documentation and share for you. Just please remind me within the week. You can remind me on Thursday or Friday because I will try to get you something. I'll try to get you something. Okay. Any more questions? Solomon is typing. Tayo.
No, sorry.
You came.
Sorry, please.
Yeah, sorry, go ahead.
Yeah, so I just want to, just a quick one before I'll not keep us here. So I just want to ask if there's like, what's your advice? Can we go and do some reading, like looking at some videos for Docker?
Yeah.
Before the next class. Oh, okay.
That would be great. You know what I'm going to do, right? The previous time I trained this, I didn't have it recorded because I was training for Elevate. But I'm going to look for a Docker 101 introduction and share it. Maybe between now and tomorrow, I'm going to share it on the WhatsApp page so people can actually go there and watch it. So that maybe to make more sense, like next week you'll be asking me questions. So, but I would like to I'll scan through the video just to make sure that it makes sense. So when I come, you guys will ask me questions, you guys will understand. I'm going to share a video. It won't be too long, maybe 2 hours 2 hours 30 minutes maximum. I'm going to look for a short video that explains Docker end to end and even does labs into it. I'm going to look for that.
All right, thank you.
All right. Okay. Boyega came on time. All right. Thank you, everyone. I think we've added extra 9 minutes. Please, if you have any more questions, maybe you remember it tomorrow, just drop it on the chat. Like I promised, I remember I promised a YouTube video. I also promised a links for learning Kubernetes security. So I'm going to look into that and paste them on the chat. So if you have any more questions, just drop it on the chat. I promised to respond within 24 hours. So if I don't respond immediately, please, if I either respond or Dominic respond, but within 24 hours, I will respond. So guys, remember next week, 6 p.m. So let's actually start by 6 p.m. so we can make use of our time and just I don't want to take all of our weekend. The ideal time is 1 hour, 30 minutes, usually to all learn and we'll grow. Thank you.
Thank you. Good night, everyone.
All right, bye-bye. Yeah, good night. Yeah.
Thank you very much.
Good night, sir.
Bye.
Yeah, good night, everybody.
Good night.
Thank you. Happy New Year. Bye.
Happy New Year, Helen. Bye-bye.
Thank you.
Bye.